this topic of Algebra 2, we'll talk about inequalities and equalities. Okay? Now, the whole section is going to be review section of what we learned in Algebra 1. Okay? So, taking those topics, reviewing them in one section, we'll move on to second section and so on. Okay? So, the first thing that we'll talk about is basically we are going to evaluate expressions. Okay, most of the people might know this, but again, this is just a review of Algebra 1. Okay, it's like test your skills. The second point is we're going to find properties of, let's say, a real number. Okay, real number. Okay. The third thing that we'll do is we're going to solve different types of linear equation. Okay, so this is the three things that we'll do in this the whole section. Okay, so then let's go ahead and start off with the first thing. Evaluate expressions. Okay, we're going to evaluate some expressions, and after I teach you the properties of it, okay, if you have forgotten something, I'll make sure that you recall each and every single objective part. Okay, so our first objective is to evaluate expressions. Now, while evaluating an expression, you need to use something called BODMAS, or order of operations. Okay, so there's two basic things that some people call it BODMAS. Okay, some people call it order of operations. Now, the whole thing, okay, both are basically the same. Okay, this and this are basically equal, as you guys can see, but both have some properties in it. Okay, now what's so special about order of operation that we need to learn? Well, we need to learn this because it's basically set of rules in mathematics. So it is set of rules. Now, I want you guys to think about a game that has no rules. Well, basically, after some time, you may end up with the answer that there is no game that has no single rules, because if there weren't any rules in a game, people would just mess up. They would do anything they want. Okay, there has to be rules to prevent stuff from happening. Okay, so there has to be rules in mathematics from preventing wrong answers from coming. So you use order of operations. Okay, if you know this, great. If you know this, okay, if you know this operation as BODMAS, great, because you know the either of them, you basically use it and you still get the same answer. Okay, now in order of operations, what we do first is let me just break every single element down. Okay, the first thing that you need to do in order of operations. Okay. Order of operations. Okay. We said that it is a set of rules. So let me just write it in a fancy way. Set of rules. Okay. Now, the first thing that you need to do is basically simplify the parentheses, brackets, and things like that. Simplify the brackets. Okay, you basically simplify the brackets or parentheses. Okay, Now the second thing you do is basically evaluate all, okay, this is important word, all the exponents. What I mean by exponents is basically you have let's say a number n, okay, and you have raised 2 over here. Now this 2 over here, okay, the 2 over here is basically known to be exponent, okay, easy as that. So what we'll do here, now let me go ahead and talk about the third thing. There's basically 4 things you need to follow. Third is basically you need to multiply and divide. Now it has a certain order, that is left to right. Okay? So you go by this order. Fourth is basically what's left. Addition and subtraction. Addition and subtraction. Okay, it has order to left to right. Easy as that. Okay? Now, what I said before is that when you have no rules in a game, it would be such a chaos, right? Every single thing would be a chaos. So in order to prevent that chaos from happening, in mathematics we have order of operation, which we said it's a set of rules. The first thing, let's go ahead and review. Okay, the first thing is simplify the brackets if you have the brackets. Now let me give you an example. Okay, now the example for this would be a bracket like that. Okay, brackets. Then you have different types of brackets. Okay, we'll go over those in our examples after this. Okay, now exponents, evaluate all the exponents. I give you an example over here. Multiply, divide, you know what multiplication and division is, but you go in a certain order. Now addition and subtraction, you know their sign, addition and subtraction, you go in left to right order. So that's basically it to understand the order of operations. Now let's go ahead and solve some examples. Okay, so our first example would be easy, but as you move on it's going to get harder and harder. Okay, now the first example, okay, is 48 plus parenthesis or brackets 12 minus 8, which is 2 is the exponent raised to 2 or squared, as you guys can see, divided by 8. How are you going to solve that? Okay, if this were given in your test, okay, this would, the first thing you need to do, the first step, okay, the step 1, rewrite the whole thing. Okay, 48 plus 12 minus 8 squared divided by 8. Second step, okay, in order of operation you follow the 4 steps. Okay, where's the parenthesis? Well, this is the parenthesis, right? 48, solve this parenthesis, we get 4. Third, the second step in order of operation is evaluate the exponent. Okay, let's go ahead and do that. This is the exponent over here. 4 raised to 2 is 16. 4 times 4, 16. Okay. The fourth step. The fifth step applied in the order of operation is basically third step. Sorry. The third step applied in order of operation is basically multiplication or division. But in this case, there is no multiplication, but it turns out that there is division. So let's go ahead and divide it. 48 plus 16 divided by 8 is basically 2. The last thing, addition or subtraction. Well, there is no subtraction, but there is addition, so let's go ahead and do that. So 50. Now what you need to do, since you got the answer, okay, but you need to follow the last step in order to get the 6 full credit. You go 50, put a bracket, okay? Well, it also turns out that if you don't do that, it's basically okay, but if you make it like that, it's gonna make teachers more understand, give them more understanding skills that how did you get that answer and what is your answer, because when you do this, 48 could be your answer, 2 could be your answer, 50 could be your answer. So some people might get confused, but it's always a good way to write your answers in a box, okay? You can also write your answer like this. Some people write it like this, but I would recommend you to write this form. So let's go ahead and solve another example. Okay, now the second problem is 15 minus 3 parenthesis 4 minus 2. Okay, now the first step we said is rewrite the equation. 15 minus 3 parenthesis 4 minus 2. Second step, parenthesis 15 minus 3, 4 minus 2 is 2. Third step, check whether multiplication or division. Well, there is no division, but there is multiplication right here. So 15 minus 3 times 2 is 6. Fourth is, when you do that, 15 minus 6, basically you get 5 plus 4, which is 9. So your answer is 9. Okay. Last step, 9. Okay. So let's go ahead and solve one more example. Now in this example, what we'll do is basically add one more equation to this problem over here. Okay. Okay, how are we going to do that? Well, all we need to do is you're going to be dividing this equation by 2 squared minus 1 and see how the answer changes. Okay, now let's go ahead and solve this. Okay, I won't rewrite it every single time because I'm the one writing the equation up on the board. Okay, but you need to do that. Okay, let's go ahead and solve this. 15 minus 3, 2, we said that, divided by the exponent, which is 2 times 2, which is 4 minus 1. Second step. Okay, second step is multiplication. 15 minus 6 divided by 4 minus 1. Okay, third step, addition or subtraction. Okay, addition or subtraction. Okay, so there's no addition, as you guys can see over here. So what we'll do over here is basically subtract. Okay, so 15 minus 6 is basically, we said it to be 9, and you divide that by 4 minus 1, which is 3. So what we need to do now is divide. Okay, this could be your answer. I mean, this is the answer, but you can even go simplify an equation that we learned in Algebra 1. Okay, how to simplify the fractions. So this is the fraction, you go by 3 times 1 is 3, 3 times 3 is 3. So the fourth step, okay, the answer is basically 3. Okay, so you see, you saw from the first equation to the last equation, okay, which is this one. Okay, the first equation we had only this part, and this third equation, okay, I just made little changes and put this under it, and you see how the answer changes from 9 to 3, okay, because it has some, this over here, it has some important to it. Okay, so basically not all the time the answers are going to be same if the equation changes. Okay, so let's move on. Let's make our way to our fourth example. Okay. And like I said before, if I have to make you guys clear, what we'll do here is basically solve more and more examples. Okay, so we get in our mind we get used to these ideas which I will be talking on the board, so that you will not make any mistakes in your quiz or test. Okay, so let's go ahead and solve this fourth. Okay, now this one is going to be a little tricky. 8xy, okay, plus 9x plus 10y. Okay, so this is the equation, and when this pops up to you, you have no idea on how to solve this. Okay, but in this case, what I will do is give you the values of x and y. Okay, and the values of x is going to be 1. The value of y is going to be 2. Simple as that. So knowing this, let's go ahead and write things down. Okay, so 8 times x, which is 1, okay, times y, which is 2, okay, plus 9 times x, which is 1, plus 10 times y, which is 2. Now you see how we wrote the whole equation in this form, okay, by the given type of form. Now let's go ahead and do things down. Okay, so what we're doing is multiplying this because we have no exponents. Okay, we have no parentheses. I wrote parentheses over here because we're actually multiplying. Okay, so when you do that, okay, you can multiply this first, this, anything you want, but you are going to get the same answer. So 8 times 1 is 8, 8 times 2 is 16, okay, plus 9 times 1 is 9, plus 10 times 2 is 20. Okay, now you can tell that this is going to be equal to 35. Okay, so this whole equation is going to be equal to 35. Now let's go ahead and solve our last example. Now this one is going to be really hard because it's not really hard, but when you look at it, it just confuses people. So we were on 5th. Okay, this is our last one. So 3 plus bracket 8 divided by 9 plus 2 bracket -4 close bracket close bracket close bracket. Okay, so how the heck are you going to solve this equation over here? Well, it's pretty easy because if you just follow the rules, you basically get the answer. So let's go ahead and follow the rules which order of operation tells us, okay? And we will be following the 4 rules that the order of operation told us, and we'll basically arrive at the answer, and hopefully it's going to be a right answer. Okay, so 3 plus, what we need to do is basically solve stuff in the brackets first. Okay, so 8 divided by bracket 9 plus 2, we aren't going to touch that. 2 times -4, what's that? 9 plus 2 times -4, we can convince ourselves, and it's -8, right? So we solve this part over here. Okay, now let's go ahead and solve this part. Okay, we're going to add this first because this is in the parentheses. Okay, if you have addition or subtraction in parentheses, you need to solve that first. Okay, they might give you an equation where you have a parenthesis and outside the parentheses you have a multiplication sign, but what you need to do here, you have division sign, but it's in the brackets but it's not in the parentheses. Okay, so let's go ahead and solve that. 3 plus 8 divided by parentheses 9 plus negative 8, or 9 minus 8, we can convince ourselves it's 1. Okay, now what we need to do is remove all this parentheses. 3 plus bracket, you remove all this parentheses. Okay, I don't need that. So 8 divided by 1, which is basically 8. Now you remove this parenthesis. You see how we're going down. Okay, 3 plus 8 is 11, and 11 is your answer. Yep. So this has to be correct no matter what, because we followed the first step of order operations, second step, third step, fourth step, and when you follow all these 4 steps, okay, correctly, you have to get the answer correct no matter what. Okay, that's all there is to it. Now, what we are going to do over here is basically discuss on what are natural numbers, what are whole numbers, what are rational numbers, what are irrational numbers, and what are real numbers. Now, many people get confused, even though they learned it before and they think they're escaped from it. But no, as we move on to Algebra 2, it takes all these ideas, all these concepts, and put these ideas into one single thing, okay? And that's the reason why we think it's hard, but really, it's not, because all those simple little ideas is just mixed and jumbled and crumpled, whatever you can say, into one single idea, okay? And it's basically really easy to understand if you just concentrate on the focus on the idea which the book is trying to tell us. Okay, so here, what I will do here is basically teach you these ideas, and hopefully you will remember. But how am I going to teach you guys here? Now, here I'll be teaching you guys that even after watching this video, small parts of it, you can tell, you are going to remember what are all the types of numbers, which are natural numbers, whole numbers, and I'm going to give you a trick or tips, you guys can say, to remember those idea or concepts. So let's go ahead and start off with natural numbers. Okay, natural numbers. Natural numbers. Now, you may have remembered that natural numbers starts with 1, 2, 3, 4 to infinity. Okay? Just goes on forever. Okay? When you put this 3 little dots, you don't need to write infinity, but it does. Okay? So basically, it goes from 1, it starts with 1 to infinity. Now, here, like I told you, I'll give you some trick to remember the natural numbers and the whole numbers. What's the difference between them? Notice that whole starts with O over here. It has 0. You guys can O in its alphabets, right? But think of it as 0. Okay? So when you think of it as 0, just write 0 over here and write the natural number down. 0, 1, 2, 3, 4, blah blah blah. Goes on forever. Okay? Wasn't it easy to remember what our natural numbers are? Now let's make our way to integers. Okay? Integers. Integers was a hard concept back in the days to make us remember, because we were introduced to negative numbers, okay, and positive numbers at the same time, okay. We accepted the fact that there are positive numbers, but it was hard to understand that there were negative numbers playing part of a role in our life, okay. So integers are basically from negative infinity to, let's say, negative 2, negative 1, 0, 1, 2, blah blah blah, goes on forever, okay. 2 to infinity, that's the integers, okay. Now here we'll also talk about rational numbers and irrational numbers, and here I'll be giving you a tip to remember those kind of. Okay, now rational numbers is basically negative 6, that's negative 7 divided by 5, then it can be 0, could be 1/2, okay. These are the rational numbers. Now rational numbers are basically the type of numbers, okay, the type of numbers that basically repeats itself. Okay? It repeats itself. It's like you can say it as a repeating number. Goes on and on and on and on. Terminating number. Okay? And basically, if you know this concept, you know irrational number. Okay? I don't even have to tell you guys, because you see rational and irrational. Okay? The prefix ir, look at the prefix ir. It means the opposite of the rational. Irrational, opposite of rational. Well, if the rational numbers are repeating numbers, then irrational are non-repeating numbers. Okay? So wasn't it easy to understand that? Irrational numbers are basically square root of 2. Let's say pi. Okay? Then 4 plus square root of 3. Okay? Now, all these numbers over here are basically known to be real numbers. So what I've done is drawn the picture of the things that we learned so far. Okay, so far we talked about different types of numbers. Okay, that is real numbers, irrational numbers, rational numbers, integers, whole numbers, okay, natural numbers. So I just drew the diagram which consists of this many types of numbers. So let me just go through this. Okay, again. Irrational numbers are numbers that do not terminate, so it doesn't repeat itself. Rational number repeats itself. Real numbers consist of all these things. That is the reason why big circle is a real number, and all of these sets are in the big circle. Okay? Natural numbers are from 1 to infinity. Whole numbers are from 0 to infinity. Integers are consisting of negative infinity to positive infinity, including 0. Rational numbers, like we said, repeating numbers. Okay, so what I want you guys to do over here, what I will do over here, is basically talk some basic types of properties that are communicative property, associative property, and things like that. So let me go erase the board first, and let's go ahead and talk about it. Okay, it's not really hard to understand this type of property once you get a visual example of it. Okay, like using the variables. Okay, once you get the example by using the variables, it's not really hard to understand this types of property. So let me go ahead and talk about this properties. So what we'll talk about is basic properties. Okay, so basic properties. The first one that comes up to our list is basically commutative properties. Okay, now this is being divided, okay, let me just write it over here, in addition, okay, in addition, and multiplication. And here we'll see how. Okay, so let me write it over here. The commutative property of addition basically says that if you have an A number and you add it to a B number, what you get is basically equal to B plus A. And we all accept that, don't we? Same with multiplication. When you multiply A times B, you get B times A, which is equal to each other. Okay, so we talk about the first property. Let's go ahead and talk about the second property. Second property is associative property. Associative property consists of, and this is a tricky one over here, A plus B, okay? You add C to it, which basically is equal to A plus B plus C. Okay? Because if you add, all you're doing is basically adding. Over here, all you're doing is, remember from order of operations, what we did over here is basically in this type of equation, if you need to solve it, all you need to do is solve the parenthesis first and then do whatever the rest part. The rest part over here is just addition. Okay, so here, as you guys can see, all you're doing is adding this and adding A to it. Here, all you're doing is addition. So it's basically saying A plus B plus C is equal to C plus B plus A. We all know that is true. So let's go ahead and see the multiplication property. Now, A times B times C is equal to A times B times C. And we all know that's true as well. So let's go ahead and talk about the third property. Okay, the third property is basically known to be identity property. And personally, I feel that this is the easiest one to understand. Okay, when I learned this, I thought this was the easiest one to learn. Okay, so it basically says A plus 0 is equal to A. What it means over here is basically it's saying that whatever number you take, you add it to 0. All you do is get back the number you put into the equation. Okay, here in multiplication, all you do is we can't put 0 here because any number times 0 is equal to 0, and what we need to do is get that number what we put in. So let's say we put in A, what we want is result as A. So if you want to multiply, you can think of it as multiplying it by 1. Okay, when you do that, you get what you put in into the equation. Okay, now inverse property. 4. Inverse property says that A plus that number, negative A, is always equal to 0. Okay? That basically in multiplication, A times 1A, which is the number, you're always going to get the answer to be 1. Okay? Last there's one more property which everybody knows who basically aced in and not aced in algebra, but basically know algebra pretty well, which is basically distributive property. Okay, and we'll talk about that property once we once we stop talking about this four properties over here. So the first property basically is a communicative communicative property, which basically says this. In multiplication it means this. Second is associative property. Third is identity property. Fourth is inverse property. So let's go ahead and erase the board and let's talk about the distributive property. Okay, and I hope you have written these things down. Now I'm only going to erase the first one, and I hope that I will make it clear. Okay, so the fifth property, which is distributive, property, okay, which basically means that A times B plus C is equal to A times B plus A times C, because you're distributing A to this values, A times B plus A times C, plus here plus is there because it doesn't have to be always plus, okay? It basically depends what the sign is inside the equation. So if you were to have minus over here, A times B minus A times C, okay? But for this example, I'm just going to be using A, B plus C, so basically A times B plus A times C. That is for addition, okay? Because you see we're using addition sign over here. So let's go and look at the multiplication. For multiplication, basically you're multiplying this in here as well. So basically this over here relates to multiplication and addition as well. So there's nothing two parts to it like we had over here. Basically multiplication is involved over here, addition is involved over here. Okay? So now that we know this, let's go ahead and solve some examples. Okay? What I mean by solving some examples is that I'll give you some type of property, like such as this one. It could be any random property that we talked about deeply, okay? And hopefully you learned it. Okay? So let's go ahead. The first is 4 plus 9 multiplied by 6 gives you 4 times 6 plus 4 times 9. What is it? Second is x plus y plus 0 is equal to x plus y. Third, 3 times 2x times y is equal to 3 times 2 times xy. What are its properties? Now, this may seem a little bit tricky to you at first glance, but really it's not that much hard. So let's go ahead and name these types of properties. Well, the first one over here is what we talked about it at the last, which is distributive property. Why? Because you're distributing 6 to these two numbers, 4 times 6, and you're using the sign which is in the middle, plus 4 times 9, okay? Two numbers. So let's name it. We know that it's distributive property. Easy much, alright? So next one may seem a little bit hard to understand, but really it's basically trying to tell us that 0, when you add 0 to a number, it basically has nothing to it towards it. So x plus y plus 0 is equal to x plus y. Some value of x plus some value of y is equal to that value of x plus that value of y. Okay, and it basically is the commutative property. Now recall that we can't just write commutative property because there's addition and multiplication. So we need to be specific in this types of thing, that it's commutative property of, what is it? Well, basically you're adding stuff, right? Addition, so it's addition. Okay, I hope I made you guys clear about that. And here, basically what you're doing is multiplying. All you're doing is multiplying. You're not adding or subtracting. So we know that without knowing what property is it, we know it's multiplying. Right? And when you go through it, it basically is the associative property of multiplication. So, congratulations guys, you have basically crossed one more border of this type of basic properties, and what we'll do now is basically simplify some expressions. Okay, we have basically two variables, and we need to find a specific variable. Okay, so let's go ahead and do that. Okay, so basically the first equation here is basically trying to tell us that simplify this. Simplify the following. Okay, you have 3 times 2x plus y minus x minus 3y. Okay, now you might be saying, well, hello smart guy, what are we doing over here? Well, basically what we are doing is basically using the concepts, or I should say concept that we learned before, that is order of operation. We basically have to use the order of operations and the concept that we learned from the basic properties, okay, that we just talked about a moment ago. So let's go ahead and simplify what they're trying to tell us, okay, or what am I trying to tell you guys. Okay, so first thing you do is 3 times 2, 6. What about the x? Just put x over here. Plus 3 times y is 3y. We'll accept that. Minus, because there is a minus sign over here. X minus 3y. Okay, now what you need to do is basically combine the like terms. What I mean by that is basically, let me just tell you here. You have x value and x value, okay? You have y value over here, you have y value over here, 3y, 3y, okay? So, let's go ahead and solve it. So basically, after you solve it, okay, you basically end up is with, oops, type over here, because minus minus becomes positive, right? So, sorry for that, okay? Now, here, when you solve it, would be the second step. The third step basically gives you the answer. The answer to that is basically 5x. You're adding 3y plus 3y, which basically is 6y. Okay, so I hope I made this problems clear to you guys. So let's go ahead and solve one more example. That basically is, I'm kind of getting confused over here for some reason. But sorry about that, guys. Okay, now second is 3 plus a plus b is equal to a plus b plus 3. And we need to find that is the following true or false. Okay, now to find that, we basically need, we can totally tell that whatever replace it, whatever value over here, you replace it has to be equal to L, or in other words, LHS is equal to RHS. Now if you don't know what that means, it basically says the left hand side, which is this one, is equal to right hand side, and we can tell that. Let's go ahead and solve it if we need to know how it's true. So let's replace A with 1, let's replace B with 0 for the clear understanding. Okay, now 3 plus A, which is 1 plus 0, is equal to 1 plus 0 plus 3. Let's take this out. 3 plus 1 plus 0 is 1, is equal to 1 plus 3. 3 plus 1 is 4. 4 is equal to 1 plus 3, which is 4. Absolutely correct. So, yep, this is correct, and now we need to tell what type of property are we using. Well, the type of property that we are using, and you should be knowing this, and it's the associative property of addition, because we're doing addition over here, not subtraction. So let's go ahead and basically talk about properties of equality. Okay, so let me just erase the board over here. So we'll be talking about the properties of equality. Okay, so let me just okay, the first property is reflexive. Property of equality. I'm just gonna write this. Okay, now it says that so less much space over here, but it says that for any real number, for any real numbers, that is A, okay, any real numbers, A has to be equal to A. Recall that real number consists of many types of numbers. Okay, we should know that by now. Second, okay, is basically symmetric property of inequality. Symmetric property of equality. Okay, that says that for any real number, okay, for any real number, A value and B, okay, if let's say A is equal to B, so both are congruent to each other, then what we can say is B is equal to A. Well, some of these things are basically so much blatant, okay, so much you can guess it. Well, okay, the third one is transitive property of equality. Okay, basically says for any real number, if
A, B, and C. Okay, you have value A, B, and C. If A is equal to B, and if you know that B is equal to C, we can predict that A is equal to C. That is the reason why it's called transitive property. It's, if you move on, since this is Algebra 2, so I'm hoping that you guys learn geometry. So there's something called a transitive property. You can prove in a theorem transitive property. Okay, we can prove this by transitive property and stuff. And as you move on, there's addition and subtraction property, multiplication and division property. But what I'm going to do here is basically I wrote down 3 properties. We talked about on them, so I'm going to erase this over here and talk about the last 2 remaining properties. Okay, so let's go ahead and erase this. So you have the 4th property, which is addition. Just gonna write and subtraction property of equivalence. Okay, that basically says that if you were to have a number A, B, C. Okay, if you were to have this type of numbers, and if you know that A plus B is equal to C, then you can guess that A minus C, you can guess this part over here, that A minus C is equal to B minus C. Okay, this may take a little time to think about, but what I recommend you is basically switch A with some value. Okay, use this number, okay, both should be equal to C, and you'll soon find out that that is true. The 5th one is multiplication and division property of equality. Okay, now that basically says that if you have A, B, C, like we did before, okay, and if you know that A is equal to B, so both should be equal, then we can say that this part over here, that A times C is equal to B. Okay, A times C is equal to B times C. Okay, so that's basically it. Or A divided by C is equal to B divided by C. Basically, you need to have this is the key to it, because A should be congruent to B over here to make this equations happen. Now, what we did here is basically use all these types of property, talked over it. Now let's go ahead and let me give you guys an example. There's 3 examples that I'm going to give you. There's on the top of my head. So let's go ahead and find it. Okay, so first one says that 28 is equal to 6x plus 4. Okay, then you have that says 6x plus 4 is equal to 28. What type of property is it? Well, we know that this is equal to this and this is equal to this, so it's basically symmetric. Symmetric property. Okay. Second, as we move on, x plus 5 is equal to 7 plus 8. Okay, that basically says 7 plus 8 is equal to 15. X plus 5 is equal to 15. What type of property is it? Well, basically it's trying to tell us that A is equal to B, B is equal to C, then
A is equal to C, right? So basically we told that it's a transitive property, okay, of equality. Okay, let's look at the final one. And I hope this one should be tricky, but it shouldn't be hard at all. Okay, x plus 8 is equal to 12, x is equal to 4. This is basically a subtraction property, because what you're doing is subtracting 8 from both sides, right? So in order to find the value of x. So if you do that, it's basically subtraction property. Now, it's for addition property also. Okay? So if I'm confusing you guys, go back where I started this, learn, and come back with me. Okay? So now what we are going to do here is basically solve some equations. Okay? So that is finding the value of a variable. Okay? In order to find the value of variables. Okay? And again, I won't go in deep into that because I think you already learned it in your geometry course or Algebra 1 course. So I won't go too much in detail about on how to do that, okay? Or you can find it in my playlist if you don't get it, okay? So the first one basically says 8x minus 1 is equal to 15. Now what you need to do first, at first time, add 1 on both sides. So here you have written 8x is equal to 16. Divide on 8 on both sides. Okay, x is equal to 16 over 8, which basically is x is equal to 2. Okay, so now let's go ahead and check the solution. 8 times x we found out to be 2. 8 times 2 minus 1 is equal to 15. 8 times 2 is, we said, to be 16. Minus 1 is 15. 15 is equal to 15. Absolutely right. Okay? Basically, you need to check for the solutions on what you are doing. Now, here I'll be talking about the phrases that people use, such as your textbook, whoever wrote the textbook, okay? They use these types of phrases or keywords, as you guys can tell, in order to express some kind of let's say they use, for example, I'm just gonna give you a taster on how they say. They say sum of something increased by, then it can say difference of something, or decreased by, product of something, or times or twice something, quotient of something, or average of something. Basically, all it is trying to tell us is basically a mathematical symbol, okay? When it says increasing, you know, it's increasing, so addition, decreasing, subtraction, average, division, okay? That's basically it. Times, multiplication. So here I'll be focusing on that types of word, because as we move on, we'll use a lot of types of these words, okay? So let's go ahead and understand that. Now, sum, I'm just gonna tell you guys, okay? Sum, I want you guys to write down the notes. So the first thing is sum, which is addition, okay? Sum includes many different parts, such as the first part is increased by, okay? When they use the keywords increased by, it means addition. Added to a number, okay? Added to, still an addition. More than a number, more than, okay? Still addition. The total of, still addition. And, okay, and even if they just used and, it's basically addition. Okay, now let's move on to subtraction signs, which is basically known to be a difference of something. Okay, now they may say it as 3 types of ways, which is decreased by this amount of number. Okay, subtracted from, or less than. Okay, now the third thing is the product, which is multiplication. Okay, they might just say double, but you know double means 2 times 2, right? Multiplied by, times the number, okay? Twice, times 2, okay? Times the number. Of,
of basically says the multiplication. Okay, now let's go ahead and go to division, which is basically quotient. Okay, now this over here has only two ways to represent, so it's not that hard. So the first one is basically average. You know it's division. The second one is basically divided by. It's not really hard to understand these types of concepts, right? So if I were to tell you that X number increased by 8, well, how would you write that? Let's go ahead and look it up over here. Recall, I said X number increased by 8. Basically, X number increased by, we said it's addition, by 8. Just write it. Perfect. Yep, you got it. Twice the sum of a number and 4. How would you write that? Well, twice, 2 times a number plus 4. Okay, twice the number plus 4. And we use the distributive property. 2 times n is 2n plus 2 times 4 is 8. So your answer would be this. Okay, now if you solve it further, now if you were to just write in the speech form 2 times the number plus 4, then you just write it as 2n plus 4. But when you use the distributive property, it becomes over here. Okay, so let's move on to the third one. Okay, this is first one, second, third. This would be our last one. 3 decreased by 3 times the number. Okay, that basically tells us 3 decreased by 3 times a number. That's basically it. What we wrote is basically correct. Okay, so when you have times 3, it's basically 3 decreased by 3 times number. 3 minus 3x. Okay, and that is the reason why it doesn't go out. 0x. Okay, it's not possible. 3 decreased by 3 times a number. So I hope I made this concept as much clear as I can. Okay, so now basically we don't have anything over here in this section. Okay, that, or you know what, I'm gonna cover it. Okay, and so here we'll be talking about absolute values. Okay, so the absolute value of something is basically a result in a positive number. What I mean by that is basically if you have, let's say, absolutely right here. This is a sign of absolute bars. When you have a negative number inside that bar, basically results in a positive number. Okay, no matter what type of number it is, okay, it would always come out to be a positive number. Okay, and also one more thing that I want you guys to focus on is that absolute value of something, let's say x minus x, is never ever going to be equal to a negative number. Okay, it's never ever going. Negative x is always going to be equal to a positive number. Okay, because remember, when x comes out of the brackets, it's a positive number. It's no longer a negative number. So it cannot, okay, no matter what, cannot be equal to a negative number. I want you guys to focus on this one, okay, because we'll use this concept and I'll give you different problems in my next section, okay, section 2, where we'll be talking about linear relation and functions, okay, of Algebra 2. So I will give you an example on that, and some people might get confused, okay, so I want you guys to focus on that. So let's go ahead and solve some examples. What is the absolute value of something? Now, just to get started, we should know that absolute value of -6 would result in +6. Okay? So let's go ahead and solve some equations. Now, if you were to have an absolute value, x minus 6 is equal to 2x. Okay?
what you would do is take this brackets out. X minus 6 is equal to 2x, okay, minus x on both sides. Negative 6 is equal to x, okay. So basically you got the answer, okay. But there's one more thing towards it. When you have negative 6 over here, it could always be result in a negative 2, okay. That would basically look like when you break it down over here in the second step, okay, it would always look like x minus 6 is equal to negative 2x, okay. So what you're doing now is basically subtracting x from both sides, okay. Minus 6 is equal to negative 3x. Divide on both sides, negative 3, negative cancels out, negative 3. 2 is equal to x. So basically there's two possibilities of the x, okay? And you can basically put x values over here, any x values, and you will get that x values, okay? But one important key is if you use negative 6 as an x, you need to use negative 6 over here. If you use 2 over here, you need to use 2 over here in order to make this equation happen, okay? Now that we know how to solve some absolute values, let's go ahead and solve compound sentence and absolute values inequalities, okay? So let's go ahead and do that. Basically, if you have, let's say, solve this example, and I'll explain to you as I'm teaching. X plus 6 is greater than 8, and if you have x minus 2, it's less than 5. Okay, how would you do that? Well, let's take the first equation, first one. X plus 6 is greater than 8. You subtract 6 on both sides, you get x is greater than 2. Okay, let's look at the second one over here. X minus 2 is less than 5, so add 2 to both sides. X is always less than 5, 6, 7. And there you go. You have your answer. And even you need to plot it on an integer plane. You basically have an x, the middle, x is greater than 2, okay, let me just write it over here, x is greater than 2 and less than 7. So basically how would you rewrite it? Well, you would write it as, you have a 2 over here, which is open, okay, and then it goes from 2 to 7, goes in this direction, if you guys can see, okay. And we can also write it this as, if you have 2 over here, 7 here, the pathway between this, that is 3, 4, 5, 6, can be the value of x. Okay, so I hope you guys understand these problems, okay. Thank you for watching, I guess.